Hi, welcome back to the
No.
vlogs.
No. What? For real?
Okay, so we are going to talk about 6.6 days. Inequalities in one triangle.
Memory.
There we go, beautiful. Okay, inequalities in one triangle. Triangle inequality theorem. Okay, each side of a triangle is shorter than the sum of the other two sides. Meaning, if I take side AB, okay, side AB, and add it to side AC, it's going to be greater than the length of BC. If I take the side AB and add it to the side of BC, it's going to be greater than the length of AC. If I take the side of BC and add it to the side of AC, it's going to be greater than the length of AB. Two sides added together on a triangle will always be greater than the third side. Triangle inequality theorem. If the two side measurements that they give you are not greater than the third side when they're added together, it's not a triangle. And they're going to give you problems like that in your homework tonight. They're going to say, here's three measurements. Tell me if this is a triangle or not. So you have to check it all three ways. You have to do, so if it's like 5, 4, 3, you have to do 5 plus 4, is that greater than 3? You have to do 4 plus 3, is that greater than 5? You have to do 5 plus 3, is that greater than 4? Get what I'm saying? Okay. Unequal sides theorem, okay, is a longer triangle side is opposite a greater angle, okay? A longer triangle side is opposite a greater angle. So if in a triangle two sides are unequal in length, then the angle opposite the longer side is greater than the angle opposite the shorter side. So that means this. If BC, side BC, is greater than AC, can you tell that that's clear?
Yes.
Okay. If side BC is greater than side AC, that means the measure of angle A is going to be greater than the measure of angle B. Here's why. This side is going to correspond with this angle that's opposite of it. So if this side's greater, this angle should also be greater. Okay? This side corresponds with that angle. Okay, so if this side's shorter, that angle has to be smaller. Okay, same over here. If this side is greater than this side, that angle is going to be larger. Okay? That makes sense now when you think of a right triangle. The hypotenuse is always the longest side. It's always opposite of what angle? 90. Can 90 be the largest angle in a right triangle? Yes. Okay, so that should help you a little bit when you're setting up Pythagorean theorem now. Okay. There we go. Okay. The hinge theorem. Okay, the hinge theorem says if two sides of a triangle are congruent to those of another triangle, but the included angles are not congruent, then the longer third side is opposite the greater included angle. Okay, we're going to talk about what that means, because that's wordy. Okay, if two sides of a triangle are congruent, so side BC is congruent with side FE. Okay. side BC and FE are congruent right there. Side AC and side DF are congruent, okay? And the measure of angle C is greater than the measure of angle F, then that means that side AB is going to be greater than side DE. This makes sense after what we just talked about. Because what angle does this correspond to, like, does this side go with? Goes with C. What angle does this side go with? F. So if angle C is greater than angle F, which side is greater? AB. That's it. That's what this is saying. Okay, so if you use the common sense from the last theorem, then you can apply it to this theorem. That's how they get this one, okay? Common sense tells me that if one side of a triangle is greater than the other side of a triangle, then that means that the angle opposite is greater than the angle opposite the other side. Now we're just doing it with two triangles. Okay, so whatever side is longer, the angle opposite is always greater. Whether it's with two triangles or with one triangle. Whatever side is longer, the angle opposite is always greater than the angle opposite the shorter side, okay? That's basically what both of those are saying. Just one's with one triangle, and this one, hinge theorem, is with two triangles. Okay, it all hinges on which angle is greater. That's where they get that from. This is all theorems today. I know, I'm sorry. This is like literally all there is. Okay, so the hinge theorem and its converse. Okay, because there is a converse to it. What's the converse always?
Opposite.
The opposite, okay? So the hinge theorem, which we just talked about, is if two sides of a triangle are congruent to those of another triangle, but the included angles are not congruent, then the longer third side is opposite the greater included angle. What do you think the converse of that's gonna say?
The angle is larger than the
Yeah. Okay, if two sides of a triangle are congruent to those of another triangle, but the third sides are not congruent, then the larger included angle is opposite the longer third side. So this one's saying, if I know what the angle measures are that are included, then I can know which side is longer. The converse is saying, if I know which side is longer, which third side is longer, then I can know which included angle is greater. So this is, I know the angle, I'm finding the side. The converse is, I know the side, I'm finding the angle. So, let's look at something I'm going to draw on the board. Okay. Okay. So, you have a triangle who has two sides, the lengths are 5 and 9. It wants us to write an inequality to describe the possible side lengths of the third side. How would I do that? What do you know that the triangles have to do? What does it have to be? It goes back to the first theorem that we copied down. What's the first theorem say?
Each side of a triangle will be greater than the third side.
Right, each side of a triangle will be greater than the third side. Okay, so when you have something that gives you two measurements, here's how you're going to set it up. Whichever one is largest, whichever side that they give you is largest, goes on the side of the inequality where it says it has to be greater than that, okay? Because if I take 5, which is the smaller side right now, and add it to my third side, those two have to add to be greater than this largest side that I have right now, okay? I can solve it that way easier because you always wanna take the largest number, because if I would put 5 over here, I could get a number over here that works for what's greater than 5, but not what's greater than 9. Does that make sense? Okay, so when you're setting up an inequality for this, you're simply solving this way. Now, I set this up first, I subtract, I don't know why, because I was thinking what 5, but, and I get x is greater than 4, yes? Okay, now you have to set up one more inequality, because that's not like gotten it down to one number for me, right? Or gotten it down to a good range, I just know it's greater than 4 in this case. So x is greater than 4. So now you have to take, okay, what 5 and 9 added together are, okay? Because remember, two sides added together have to be greater than the third side, right? And you have to say is greater than side x, okay? So 14 is greater than x, correct? Okay, so now I know what my parameters are. X has to be greater than 4, but it has to be less than, so I would say, 14 is greater than x, x is greater than 4. Or you can write it as, or you can write it individually, where you say x is greater than 4 and x is less than 14. You can write it either of these two ways, because they say the same thing. Okay, so now you know what numbers you could have as your third side to make a triangle. You're going to have to do that on your homework. Okay? Let's say you have two triangles. 60, these are, I always have to tell Connor when, these are not to scale, so just pretend, okay? Because he's always like, is that to scale? I'm like, shut up, Connor. Okay, so you have this triangle and it's labeled this way. You have another triangle and it's labeled 657.4. Okay, it says, implying the unequal side theorem, okay? The longest side of a triangle would be across from its greatest angle. Does that make sense? Is that true? Is the greatest angle across from the longest side?
Yes.
Yes, and then the second, and then the third, okay? It says in a triangle ABC, which we don't have a triangle ABC, but we'll just name that triangle ABC. Okay, the measure of angle B, let's say that this is triangle ABC. Let me think about this. The measure of angle B is half of the measure of angle A. Okay, so the measure of angle B is half the measure of angle A. And the measure of angle C equals 30 degrees, okay? Now this triangle is not labeled. It's not labeled for a purpose because they're gonna have you decide which one's A, B, and C, okay? So the measure of angle A, the measure of angle B is half the measure of angle A, and the measure of angle C is 30 degrees. Place the angles correctly on this triangle. What would I do?
Use ratios
Mm,
from that triangle to that.
nope, I'm not comparing, this was just to prove to you that it's opposite, that we're not looking at this right now. I want this, and I want you to tell me which one's A, B, and C on this triangle.
Would you use the converse of the hinge? Because we have to find the angles.
You do have to find the angles. We're gonna have to set up some equations. How could I do that? Let's take it one step at a time. What does it say about B? The measure of angle B is what? Half of, so,
A can be X.
I can represent the measure of angle B this way. Equals 1/2 the measure of angle A. You have an equation. What does it say C is?
30.
C is 30, so the measure of angle C equals 30. We know what that is. How can I figure out what A is?
When you add them all together, is it equal to 180?
Yeah, when I add all of them together, it equals 180, you are correct. So the measure of angle A plus the measure of angle B plus the measure of angle C should equal 180. The problem is, I know what C is, correct?
Yes.
Okay. Do I know, you know that C is 30 degrees. Wait, is that what I said?
Yeah.
Oh, let's do this. Let's add something to this. The measure of angle C is 30 degrees. Let's make it a little easier. Let's say the measure of angle C is 30 degrees less than A. That way we can change this to the measure of angle A minus 30, okay? That way we can plug some stuff in. So now what can I plug in?
What B equals what C is?
Yes, so I have the measure of angle A plus, what's the actual measure of angle B?
1/2 the measure of angle
1/2 the measure of angle A. Plus, what's the measure of angle C?
A. Measure of angle A minus 30.
Measure of angle A minus 30 equals 180, okay? So now, okay, you can start to solve from here. What do I need to do first?
Add 30.
You wanna add 30? Okay, so I have the measure of angle A plus 1/2 the measure of angle A plus the measure of angle A equals, 210, is that correct? Yes, okay, equals 210. From there, what am I gonna do?
Can you add the measure of angle A and the measure of angle A together?
Okay, so there's like two of these, right?
So you take the 1/8, the 1/2,
Take what, 1/2?
like, divide 210.
Well, technically, let's look at something. Let's say that these say X here. What would I do if it says X plus 1/2 X plus X?
Combine the two.
And what would you get?
2.5x.
2.5X. Okay, so I technically have 2.5 measure of angle A equals 210. Do you get what I just did? Okay, so how do I get rid of this 2.5 now? Yeah, you divide it by 2.5, right? Okay, so I divide it by 2.5. What is 180 divided by 2.5? Or what's 210 divided by 2.5, sorry?
Right by 1.5 or
2.5.
84.
It's what?
84.
So what is the measure of angle A?
84 is
Now, how can I figure out what C and B are?
180. Plug it back in.
Multiply, or, no, plug it in.
Plug it in. So the measure of angle B equals 1/2 of 84, which gives me what?
42.
42 degrees.
And then 54.
And then what?
54.
Because I'm doing 84 minus 30, right? So we applied the knowledge we have. Now we can check. If C, because we have to label, if C is 54, okay, A is 84 and B is 42, which one is the smallest angle?
Angle B.
Angle B. So where would it go on this triangle?
In the far right.
Right here. Because it's
It's
opposite of 5. Where does the largest one go, which is 84? Where's A go?
Opposite of 7.4.
And then this is, and that's how they want you to solve that. Does that make sense?
Yeah.
Okay, so that is what you are going to work on today. Cool?
like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Maya?
Way my freaking blow.